I want to introduce now Cory Brown. Cory Brown is a front-end engineer at Omni, our premier sponsor today. Formerly worked at Facebook, Nav, Jane, the LDS Church, and National Geographic. Cory has been writing JavaScript for over a decade. Front-end is his joy, JavaScript is his love, and empowering others is his calling. Cory leans functional. Please welcome to the stage, Cory Brown.
Thank you. Let's start this off right.
We gotta find a way to make this fit into the hole for this, using nothing but that.
Okay. So, Feskerma, everyone. Hami leitolekcha avian shoanju. Is Mishakori agus she priv leishakjen Leon anam ek omni. Agus hami against a kukalek. Thank you for indulging me in that. My name is Cory Brown. I occasionally tweet at unique name. I very rarely tweet at 365JS Things. I sometimes blog at 365JSThings.tech, and I work for an incredible company called Omni. Maybe you've heard of them. They're pretty awesome. And yes, thank you for asking. We are hiring. Okay, let's get into this. So we got about, we got a little bit more. Maybe a little more than a third. From what we had at the start of this. This is great. All right, so when the Odyssey command module on the Apollo 13 mission suffered an explosion on one of the oxygen tanks, the mission team had a sudden change in priorities. They had hard deadlines and fixed resources. Setting aside the fact that actual lives were at stake with them, maybe this rings a little familiar to you. One of their challenges was to make two similar, incompatible components interoperate. Again, maybe you can relate. When time and resources are immovable, the only lever to pull is quality. And the results were
Deadly CO2 gas is literally
predictable. There we go.
Deadly CO2 gas is literally poisoning the astronauts with every breath in and out.
Heads up.
And spokespeople will not comment further.
Go. Heads up, people. Look out now.
Perhaps this too is something you can relate to. To accomplish this, what they were able to do, though, the engineers had to have knowledge about everything in the command module, everything in the lunar module, and everything that the astronauts were actually wearing that was on them. Imagine having to have that depth of knowledge about our code bases in order to be productive in them. I hope this is not something you can relate to, but maybe it is. So we want to be able to be productive quickly in a code base, whether we are onboarding or just switching context from one task to another. Being able to load up all the information needed in order to perform our task is an invaluable thing. Complexity in our applications work directly against this. So today, we're going to talk about how to understand more by thinking less. Or I could have alternately titled it 5-ish best practices for managing complexity. Our subject today, the thing upon which we will be applying these things, is this function. Can anyone tell me what that function does? Call it out if you can see it. It does that. It gets some page data. And it does stuff with it, right? There seems like there's a lot going on here. It gets page data. It gets that from some endpoints, a collection of endpoints, and selects from it based on the page name that we're at. It updates some app state right there based on that page data. We're going to do some different kind of app state as well. We're going to check to see if the user's an admin. If they are, we're going to update some different state. We're also going to peel off some of the transactions to have a transaction preview and update that state. If anything goes wrong along the way at different stages, we have error handlers for that. We handle them at each stage of this process. So during the course of this presentation, we're going to apply some rules that we're going to learn to that function. Those rules or those principles are: don't artificially entangle state. Pass only what is absolutely needed. Derive what can be derived. We're going to push effects, and effects include things like error handling and fetching, towards the edges. And we're going to talk a little bit about dependency injection. OK, this is very small. I'm sorry. It will get bigger as we go. I had to fit it all on here. Let's talk a little bit about not artificially entangling state. First, to do that, let's look at what our endpoint returns. We're getting something called page data, and we are immediately updating what looks like is shared global state. It's not immediately clear what this information is, though. But if we look a little further down, we can see that elsewhere, there is at least a user property and a transactions property. And these two pieces of information, just because they're named user and transactions, we can infer from that, and for our purposes, we're going to assume that these two things are largely unrelated. They will have very different reasons for changing, right? Artificially tying these two pieces of state together is similar to having people chained together. Where one goes, the others must follow. Sometimes these pieces of information will fight against each other. And sometimes this coupling is not immediately obvious to us, but we can observe it in changes in one part of our app that are very unexpected, related to where we think the changes are happening. In fact, we may feel a little bit like Einstein did when faced with the idea of quantum mechanics and quantum entanglement, where he said that, and we might say about our app, that it cannot be reconciled with the idea that our app state should represent a reality in time and space free from spooky action at a distance. Maybe you've experienced spooky action at a distance in your applications when things happen weirdly. These kinds of bugs can be extremely difficult to track down. And one way that we can actually limit the opportunity for them occurring at all is by making sure that state that is not inherently coupled remains separate from each other. Many of the tools that we use help us to do this, to prevent this from happening, but we have to take some things upon ourselves. For instance, with Redux, we have separate reducers where we keep different parts of our state. Those can be combined with combined reducer, but using the dispatch function and the types, we can specifically target those areas. And if we find later that different things are actually related, we can re-entangle them by having each of those reducers listen for the same action. We can do similar things in just plain React with use reducer hooks, or even get a deeper sense of segregation by having separate use state hooks. And if we really felt inclined for some reason, we could even go all the way back to the Flux model and have different stores for these different pieces of data. All of these are just examples of how we can keep state that is not inherently tangled separate from each other. OK, so back to our function. Let's break apart the update state function into multiple state functions, one for each distinct piece of state. See the difference there? One call, two calls. That's all we did. Since we have different state handlers, we're also going to destructure our fetch response to keep things a little clearer and reinforces state separation, isolating discrete pieces of state. So that we do this so that it eliminates the number of opportunities that inadvertently kind of create a logical coupling. This is a reinforcement mechanism to indicate to the reader that these are different and should remain so. So that's state. Do not entangle a state that is not inherently coupled together. That's one way we can reduce complexity. The next way that we're going to talk about in reducing complexity is to pass only what is needed to a function. Is your function overqualified? Does it know too much for the job it's supposed to be doing. If we take a look at our function, let's analyze this from the perspective of what does it know about the outside world? We're passing the endpoints argument, but we only use the page data property on it. Furthermore, it's only a particular property on that property that we care about. It's whatever the value of the page name argument is. Further, on the roles argument, we're only using the admin property on that. We're using the done argument in several places, but weirdly, we're not even using the feature flags argument. Why are we passing it in? So you might ask yourself, that's really interesting and all, but why is that a problem, per se? Like, why is having more information available to me an issue at all? Well, it comes down to a principle called the principle of least knowledge. It's also called the law of Demeter. As the name implies, the idea is that a given unit should have the least amount of knowledge necessary about its surrounding context in order to perform its job. It's related to the single responsibility principle, which you probably have heard of. And if you let it, it can change your life. Okay, that's maybe a little overdramatic, but it's a really good principle to keep in mind. Often we talk about this concept, this principle, in terms of the metaphor of a black box. We find that metaphorically, we put stuff into this box and magic happens. Out comes some result. We don't see anything enter the box. We have no direct information about what's going into the box. We just know that, or I'm saying what's going on inside the box. We just know that we give it some particular piece of information and some other particular piece of information comes out the other end. It's a useful metaphor, I think, for this principle, but it's only halfway there. I think it's also useful for us to look at this from the concept of being inside the box. From the perspective of inside the box, there are no two-way mirrors, there are no peepholes, there are no windows inside the box. The box itself does not know anything about what's going on the outside. From the box's perspective, stuff shows up on its front porch. It picks it up, walks through the room, doing its thing, whatever its thing is, and drops it off on the back porch. And that's it. That's all it is aware of. It's important that we, I think, look from both perspectives of this, from the consumer of the unit and the unit itself. And doing so helps us keep our box free from contaminants and other impurities, which add complexity to our functions and to our applications. It adds non-determinism and other yucky things, other poisons. To illustrate this better, I want to offer a slightly different metaphor than a black box. I want to talk, have you guys ever seen one of these things? They're super cool and kind of like surreal when you use them. You can stick the big end into anything that presumably has water in it somewhere and suck on the straw, and you get clear, pure water at the other end. And it's a little nerve-wracking if you're putting it into something really disgusting to drink from it. But it works. It's totally wild. It's a magic box. I don't know how it works. I just know that it does. You stick the big end in yuck, and you get water out the other end. It's pretty amazing. Imagine if this straw were not properly sealed. If there were leaks around the seals, or if there were holes along the straw going up. We would definitely not be having the same experience with this product. Things would go quite differently. We don't want that for our life straws. We don't want that for our functions either. An airtight function straw is preferable to a punctured one. So let's apply this. Let's take a look at their function again and see where our gaps are. We are passing in objects that have properties that we use, but we do not use the whole object. Let me give you a real-world example of how this acts. This is contrived. This is real world, only slightly modified to protect the guilty. This is a real thing that happened to me not long ago. I've genericized it, but the principle's still here. I refactored some code to accommodate a new feature and inadvertently introduced a bug. This is typed. In theory, it should be, type safe. This should not have happened in principle, but it did. Can anyone spot the bug? Don't worry, I didn't either until the whole page blew up and I got a big white screen and nothing was functioning at all. The problem was that the code failed because message, the argument, was being passed in as undefined. Nothing was being passed to it, which means as I try to pull the properties off of the message object, it's like, nah, brah, we're not doing that, and it explodes everywhere. If we look a little bit closer at this, though, we see that the hasError function actually only cares about one thing, the status on the message. If we were applying the law of Demeter, the principle of least knowledge, instead of passing the message in there, we could pass in the message status. If we did that, my page never would have exploded. Maybe it would not have worked exactly the way it was supposed to, possibly, but at least we would have had a functioning web page. This has only the information it needs to do its job. An incidental benefit of applying this law, though, is, and this happens every time I do this, almost, when you take away some of the complexity in any given space, what tends to happen is you start to see more complexity that can be taken away. So for instance, now that we've gone this far, another step that may be readily visible to us is to refactor it like this. This is a very simple example. We might have jumped to this conclusion a lot earlier than that, but I think you see the principle. As we remove unnecessary things, we begin to see more unnecessary things. It's like tidying your room. You clean up and you find, oh, maybe I should vacuum too. It's much better if it's vacuumed. Okay. Yeah. So returning to our function, let's apply what we've learned. Let's pass in only the information we need to do our work. And doing so reveals a few other things that might seem like no-brainers to us. For instance, we should probably combine the page data endpoints and the page name arguments before we call our function instead of doing it inside the function, so that we're not doing that. This makes this a lot easier. And second, it seems like, to me, that user.role equals admin role line, we should probably have a utility for that. It feels like maybe we shouldn't be doing that directly. So we're going to do a little utility. But in doing so, let's not fall into old habits. We don't need the entire user object. All we need is their role. Great. So let's see what we've done so far. This is what we were doing, and this is what we're doing now. Pay particular attention to the arguments. We went from, 5 to 2, and we only changed 2 lines of our function body. We have radically reduced the complexity of using this function. So that's awesome. Go us. All right, next, derive what can be derived. So things are looking up for us. The next principle is to derive anything that we can derive from the state that we're already tracking. We get this idea of derivation originally from chemistry, where we derive one substance from another to produce a compound of some kind. And hold on to that word compound for a minute. My son, I'm going to tell you a story. My son has a terrific memory that is both impressive and terrifying. He's 7. He tends to remember exactly the wrong thing and will bring it up sometimes years later in just the perfectly wrong situation. He learned recently from someone, probably one of his siblings, about a Google. And in his mind, a Google and like infinity, it's synonymous. It's just a ridiculously large number. Basically the same thing for him. He asked me the other day, what is a Google minus 1? And I told him, I was like, well, it's a Google minus 1. We wouldn't really talk about it in terms of the number. We talk about it in terms of the formula for that number, because the two are so different in scale. And being the trusting, accepting, innocent child that he is, he immediately said, Alexa, what is Google minus 1? I was a little nervous. I was very happy when Alexa said, a Google minus 1 is 10 to the 100th power minus 1, proving my point that we wouldn't refer to this by the actual number, but by the formula. We would derive this number as we need it. So the point is, it would be silly, right, for us to answer, to give this number. We would say a Google -1. We can and we should apply the same idea to our code. Any information that we're able to derive, we should derive at the time that we need it and not keep multiple pieces of state that do that. So in some sense, looking back at our function, we're already doing this when we created the isAdmin utility. There's also a bit of state that we're tracking that is directly, derived from other information. Are you able to see it? It is the transactions preview. Getting rid of it right there. We actually have this information. We can derive it when we need it. We can slice off from the transactions state that we're saving on line 8 and derive it at that time. We don't need to keep that state. Similarly, since we now have the isAdmin utility, we don't actually need to track whether or not the user is an admin role. We have a function to do that based on state that we're already tracking the user object. So we can get rid of that and derive it as we need it. Nice. So we've cut down some unnecessary code. Good for us. OK. Now the fun one. Let's talk about side effects. Side effects are synonymous with complexity. If we have side effects, we have complexity. The problem is our applications are utterly useless without side effects. So how do we balance this? Right? How do we deal with the fact that we need side effects, but side effects add complexity? By following Benjamin Franklin's advice, we treat our side effects with deliberateness. Everything in its place, a place for everything, everything in its place. We know that pure functions are easier to understand and more intuitive and have fewer opportunities for errors and are consistent. It stands to reason then that we want to maximize the ratio of pure functions to impure functions in our code. One way we can do that is by continually pushing impurities, things like side effects, to the edge, to the literal edge of things. So at the beginning or the end of our function bodies. Actually, Kent just talked about that earlier when he talked about his error handling. He was able to put at the bottom and not be all intertwined with the happy path. If we were to take this to a logical conclusion, we would end up with a thin shell of impurity around a fully pure application. Now, at this extreme, there are definitely trade-offs that come with this kind of architecture. It's a bit of an extreme step. It's not really traditional JavaScriptiness. But I'd encourage you to take this. What I'd encourage you to do is take this idea back to our code bases and begin applying it at the function level. Move it to the edges, the top and the bottom of the function body. If that's comfortable, maybe we lift it out of the function up into the calling space and keep doing this, repeating this process, and see how far it goes before it starts to feel yucky, and then stop. Thank you. OK. In our function, where do we have the side effects taking place? In our error handling and in our fetch calls. So every place we need to resolve a promise, which could fail and interact with some external system, will cause a side effect. There are more, but we're just going to focus on these. The cool thing about promises is that they unwrap. So however deeply nested they are, when we then over them, we get just the value that they're containing. We can apply this by lifting some of our promises up, our thens up a little bit. We can treat promises like a functor and map over them. This map chaining enables us to have a really powerful pattern and allows us to create similar self-contained contexts just within our little pure function, creating a fractaling pattern of purity. So if we look at this, and what we can do, if we combine, let's see, we take our response OK, and we actually lift it up as part of our thenning, we can begin to collapse a whole bunch of our promise, the way we deal with promises, and create this chain of thens and catches. Now we're getting closer, but this does not work because we have 3 catches in a row, and that's just not gonna fly. But it's interesting, isn't it? Let's keep going. We see that 2 of our catches are identical, so let's get rid of one of them. Furthermore, we see that the other 2 catches are almost identical. It's just that the first one up there needs to deal with the error message that comes from calling the text, the response.text. So instead of rejecting with the whole response, if we reject with just the promise or the text call, the response.text, we can now have identical catches, and again, delete one. That's pretty good. So before our original and after, we have really reduced complexity on this function. Okay, so largely out of time, but I'm gonna briefly talk about dependency injection. It's really cool. Look into it. It's useful. However, on practical terms, I don't find it terribly useful. I don't use it much in JavaScript. It seems to fight against JavaScript things. I would still encourage you guys to look into it. And actually, if you have a really good case where it works well in JavaScript, please let me know, because I'd like to find out about that. But I find it doesn't really, it doesn't sit with me often. We'll skip over that, though. One-ish last thing. So those are the 5. I have a bonus for you. And it's to prefer return values over callbacks. See, we're doing these done callbacks. If we returned our promise instead of the done callbacks, we can get rid of the done callbacks altogether and further reduce our complexity. And actually enable the consumer of this to have more things that they can do with it, more opportunities. Super double bonus. If you've never heard of tap, look into it. It's super great. If you're going to map over things, tap is an excellent way for debugging. It's like phone tapping onto your pipeline. We can transform our then from having to destructure stuff and get the rest and do some stuff and then pass it along to our next one, to just performing the function that we care about, and then the rest, the original thing that was resolved just gets passed through underneath, and we don't have to think about it. Super cool. Look into it. It's in most libraries like Lodash and Ramda. And now, guys, this is terrific. We have a really excellent way of reducing complexity on our functions. Velkeschaken? Velkeshano? Yeah. Thanks. If you have any questions, come talk to me. I don't think we have any time for that right now, but I love talking about this sort of stuff and any ideas you guys have. Thank you very much. Bjarnak Livula.